Hi guys, this is Saurav here and welcome to Online Pathshala, Vedantu's initiative to make education accessible to everybody across the country. And how are you guys? कैसे हो आप लोग? It's lovely to see you again on this Friday. There's Pakistan-Bangladesh match going on and I am very happy that you made time for this. Okay, so today's session is on non-ideal solutions. We are discussing solutions, so colligative properties you call it. तो non-ideal solutions का आज ये second part होगा. In the first part of non-ideal solutions we had discussed about what non-ideal scenario is and what is ideal scenario. We had already understood this fact that ideal scenario is one which follows Raoult's law and non-ideal solution is one which does not follow Raoult's law. So Raoult's law talks about vapor pressure and vapor pressure वाले उस equation को अगर कोई दो solutions follow नहीं करते हैं अगर कोई solution नहीं follow करते हैं then it becomes a non-ideal solution. Okay, it becomes a non-ideal solution. So let's talk about what we are gonna study in this session. In this session, I tell you about azeotropic mixture, जो कि बच्चों को लगता है कि it's very challenging, very difficult, but it's not. Actually, it's not. It's very easy. So, azeotropic mixture is very easy to understand. In this session, we'll learn about what is the meaning of azeotropic mixture. Okay, so चलते हैं, आगे बढ़ते हैं. But before that, I like to tell you that please download the doubt solving app. Because on doubt solving app you have access to a lot of our lectures, lot of our quizzes, lot of our questions. You can post your questions, you can get them answered, and free session PDFs are also available over there. Also please do join our telegram group pe all the teachers are available. You tag the teachers to respective questions and we'll ensure that they get resolved in due time, and you can interact with other people. It can be a discussion session kind of a thing. So yeah, it's on the App Store, it's on the it's on the Google Play Store. Okay, so curious Indian, I have taken your advice and will try to ensure that there is a dark thing which can be incorporated. However, it becomes a little challenging for a number of people, but we will consider that as well. But before starting the session, I would request you guys to please like, share and subscribe our channel and our videos so that it reaches to the maximum population. It's the good comer for you for the day. And please do hit the bell icon before you like watch any video so that you're always up to date with all the awesome content. So let's start today's session, and let's start today's session with a question. Okay, आज का session हम start करते हैं question से, and the question is right on the board. You can imagine it to be an advanced level question because आप देख रहे हैं यहाँ पे question क्या है. So let's look at the question. How many of the solutions show a positive deviation from ideal behavior? How many of the solution shows positive deviation from ideal behavior? Now I had explained this to you earlier that what is the meaning of positive deviation. Positive deviation वो होता है जिसमें कि solution का vapor pressure Raoult's law से जो आपने predict किया है उससे ज़्यादा रहेगा. So according to Raoult's law, the solution vapor pressure is equal to mole fraction of component A, the first component, times its vapor pressure plus mole fraction of component B times its vapor pressure. This is what you calculate. This is what you calculate on the paper. Okay, paper में देख के आपने calculate कर लिया. But experimentally जब आप observe करते हैं, then it can be equal to this, it can be less than this, or it can be more than this. Positive deviation means it is more than this. So that means vapor pressure is more for the solution identified experimentally compared to what is predicted using Raoult's law. Now it is important to know कि इतने सारे options दिए हुए हैं. You can see that I have given you about 3, 6, so 18 options I have given you. Out of 18 options, you have to identify how many are showing positive deviation. So to identify positive deviation, remember, it would be generally a mixture of polar and non-polar. Okay, polar and non-polar, general idea polar and non-polar से आप निकाल सकते हो. So positive में polar and non-polar का अगर mixture है तो वो positive show करेगा. So let's look at what would be. Okay, so let's start with, sorry, this is N-hexane and N-heptane. Let's start with the first one, N-hexane and heptane. दोनों almost alike हैं. N-hexane and heptane homologous series में आता है. They differ by just a CH2 unit, so they will behave as ideal. They will behave as ideal. I'll write I next to what is ideal. CCl4 SiCl4. This will also be ideal. Okay? No, it's not positive, it is ideal. N-hexane, N-heptane is ideal. CCl4 SiCl4 is also ideal because both of them are non-polar. Nature is not changing. H2O HCl. Now, tell me something. H2O में अगर हम HCl डालते हैं, won't a reaction take place? Would a reaction take place or not? H2O में अगर हमने HCl डाला, would a reaction take place or not? Please tell me. Will a reaction take place? If I put HCl in H2O, will a reaction take place? Yes? Yes? Now, over here we have only hydrogen bonding. इन दोनों components में सिर्फ hydrogen bonding है, but you can see that these are ions and ions के बीच में जो force of attraction होगा, that would be electrostatic force of attraction. Okay, that would be electrostatic force of attraction, and if there is electrostatic force of attraction, attractive forces increase when they are put together, so vapor pressure will decrease and it will show negative deviation. ये negative हो जाएगा. So anything where reaction occurs will result in negative deviation. Now benzene ethyl alcohol, polar, non-polar, so this will be positive. Benzene acetone, polar, non-polar. Acetone is polar, benzene is non-polar, तो यहाँ भी positive हो गया. हेक्सेन इथेनॉल क्या होगा बताइए? हेक्सेन इथेनॉल, इथेनॉल इज पोलर, पोलर प्रोटिक सॉल्वेंट है, OH ग्रुप रहता है. हेक्सेन इज नॉन पोलर, सो इट विल बी पॉजिटिव. ओके, लेट्स एनालाइज दिस पार्ट. इथाइल ब्रोमाइड एंड इथाइल क्लोराइड, ये एक पार्ट है. इथाइल ब्रोमाइड एंड इथाइल क्लोराइड, इथाइल ब्रोमाइड एंड इथाइल क्लोराइड विल बी आइडियल. सिमिलर स्पीशीज ethyl bromide and ethyl chloride will be ideal. Benzene and toluene, benzene and toluene क्या होगा? Benzene toluene कितने का डिफरेंस है? एक CH2 का डिफरेंस है. Similar property, ideal. Okay. Acetone and aniline, acetone and aniline react with each other, and you will learn this reaction in carbonyl compounds. You will learn this reaction in carbonyl compounds. They do react with each other, and since they react, कोई दो चीजें अगर react कर रही हैं, then it will show negative deviation. Okay, negative deviation. To identify ideal, I need to see similar nature. So this was already discussed. Please do review the previous video. ये हमने पहले discuss कर लिया है. Similar nature होना चाहिए. Non-polar, they will become ideal. Carbon disulfide and acetone, as carbon disulfide is non-polar, acetone is polar, so I will get positive. Okay. CCl4 CHCl3, CHCl3 is polar, CHCl3 is polar. Okay, polar, non-polar. Okay. Now H2O and ethanol, H2O is more polar as compared to ethanol, so it will again show positive. H2O and ethanol, H2O is more polar as compared to ethanol, so this will show positive. Let's move on to this section. Chlorobenzene and bromobenzene. Chlorobenzene एंड ब्रोमोबेंजीन. क्या होना चाहिए? क्लोरोबेंजीन एंड ब्रोमोबेंजीन. दिस विल बी आइडियल. वेरी गुड. Chloroform and acetone. Chloroform and acetone react with each other. It will form a compound known as chloritone. और ये आप कार्बोनिल कंपाउंड्स में पढ़ोगे या फिर क्लोरोफॉर्म के रिएक्शन में पढ़ोगे. क्लोरोफॉर्म and the compound formed chloritone is used as a sedative or a hypnotic. Okay, so this will, since reaction takes place, negative. H2O HNO3, बताइए. H2O HNO3 would be the same case as H2O HCl, isn't it? Phosgene, no. Phosgene नहीं बनाता यार. Phosgene is formed when chloroform reacts with oxygen. So H2O HCl scenario and H2O HNO3 scenario is gonna be the same. So this will be negative. Chloroform and ethanol. Chloroform and ethanol will show positive deviation. Both are polar but different polarity. H2O methanol, positive. Acetic acid and pyridine. Acetic acid is an acidic compound. Pyridine is a basic compound. They will react with each other. हो जाएगा negative. So I have taken 18 options, 18 solutions. इससे ज़्यादा सॉल्यूशंस आपको दिए नहीं जा सकते हैं. सो 18 सॉल्यूशंस मैंने ले लिया और मैंने एक बार में लिख दिया है कि कौन कौन से आइडियल होंगे, कौन कौन से नॉन आइडियल होंगे, एंड व्हाट वुड बी द पॉजिटिव डेविएशन, व्हाट वुड बी द नेगेटिव डेविएशन. सो आवर आंसर फॉर दिस शुड बी दिस 2, 3, 4, 5, 6, 7, 8. So the answer to this will be 8. Okay, answer to this would be 8. Clear? चलिए. So I hope this is understood. सभी को समझ में आ गया. This is a very simple way of identifying how to work around this, how to work around such a question. So ever you see a question like this, don't get perturbed, don't get worried, don't get nervous. Just think of this fact that how similar is their nature, can they react, can they not react, and you can proceed ahead. Okay, so हमें कैसे पता चला कौन पोलार है? निर्मल कुमार पढ़ाई करने से पता चल जाएगा. ओके, यू विल अंडरस्टैंड कि क्या हो, कौन सा पोलार होगा. अभी आप 11th 12th में आ चुके हो. सो बाई नाउ you would have known that कौन सी चीज़ें पोलार होती है. डाइपोल मोमेंट. ओके, यू मस्ट हैव सीन क्वेश्चंस ऑन डाइपोल मोमेंट. ये सारी चीज़ें आप 11th में पढ़े हो, 10th में पढ़े हो, उसी का एप्लीकेशन है. ओके, जैसे वाटर पोलार होता है, ये मालूम होता है आपको. सो लेट्स मूव अहेड. ओके, लेट्स मूव अहेड. लेट्स टॉक अबाउट व्हाट इज एजियोट्रॉपिक मिक्सचर. सो एजियोट्रॉपिक मिक्सचर, azeotropic mixture, the word comes from a Greek, there are two words which are joined together, which means constant composition. Okay, so azeotropic mixture is a mixture of two liquids whose proportions cannot be changed by simple boiling or simple distillation. Now, do you remember we had discussed this earlier, that when we perform the process of distillation of two liquids, then the more volatile liquid separates out, the less volatile liquid is retained in that flask where we are performing it. So अगर हम ये दो liquids के solution को boil कर रहे हैं, and let's say we hit a point at which we are no longer able to separate it into two components, then we have arrived at a scenario. It is known as azeotropic mixture. So the composition remains constant. So azeotropic mixture is a mixture of two liquids whose proportions cannot be changed. This is very important. Proportions cannot be changed. You are boiling it, but whatever you are getting as the distillate has the same composition as the substance which is present in the flask. You are not getting anything else. You are not getting the more volatile component in a greater quantity. You are not getting what was happening in ideal scenario. You are getting something else. You are getting the same composition as the distillate. Distillate उसको बोलते हैं जो कि boil करने के बाद आपको मिलता है. Okay, so it is known as constant composition boiling mixture. It's known as constant composition boiling mixture or a constant boiling mixture. So the composition is not changing. It's not 1:1. Okay, it's not 1:1. That's a very, very wrong conception that it will be 1:1. That's not going to be 1:1. Will 1:1 रेशियो मैं बोल रहा ना, 1:1 रेशियो नहीं रहता है. देखते हैं क्या होता है वो. It is observed for those solutions which exhibit deviation from Raoult's law. So we just had read this part that there are solutions which show deviation from Raoult's law, positive or negative. So all solutions which show positive deviation or negative deviations will form azeotropic mixture. Okay, but where would this mixture be formed? Let's understand this in a bit detail. So let's look at this plot. Let's look at this plot. This plot is about the vapor pressure versus composition. This plot is of vapor pressure versus composition. Okay, Adarsh K, it's not 95:5. Don't say those things. Okay, it is not like that. Okay, just try to understand what is happening. So this is a curve. This is a plot for vapor pressure versus composition. Now Raoult's law says that the total vapor pressure will follow a straight line path. So let's say there are two components. दो component हमने ले लिए हैं x and y. Y has x is 0% over here. So this is vapor pressure of x. This is vapor pressure of y. If you take Raoult's law, if it is following Raoult's law, then it will follow a straight line path for the vapor pressure of solution at all compositions. आप composition ये लिया आपने और ये लिया और ये लिया और ये लिया. At all of these positions, you can calculate it using the equation P is equal to P naught x times chi x plus P naught y dot chi y. Okay, you can calculate it using this equation and the experimental result will also be exactly this. But when you are using a solution with positive deviation, then the vapor pressure will be more, and if you are taking it for negative deviation, then the vapor pressure is less. Okay, राउल्ट्स लॉ का तो स्लोप उतना ही रहेगा. राउल्ट्स लॉ अगर को फॉलो कर रहा है तो ये आइडियल के लिए ये हमेशा यही रहेगा. ओके, पॉजिटिव डेविएशन के लिए ये रहेगा एंड नेगेटिव डेविएशन मींस इट इज लेसर. नाउ व्हेन यू ड्रॉ अ कर्व, you are getting a maxima, isn't it? Aren't you getting a maxima? Can you identify there is a maxima over here? And you are also getting a minima. You're getting a minima and you're getting a maxima, isn't it? Are you able to identify that you're getting a maxima over here and you're getting a minima over here? Are you able to identify, guys? So when you're drawing it for positive deviation, you can see that you get a maxima. When you draw it for a negative deviation, the vapor pressure versus composition, you get a minima. Yes? Now, what you can see is this maxima is obtained at a particular composition. This maxima is obtained at a particular composition. Can you see this? It is not a maxima है तो ये किसी एक point पे मिलेगा हमें. So maxima is obtained at a particular composition. Minima is obtained at a particular composition. इसका मतलब एजियोट्रॉपिक मिक्सचर का मतलब ये नहीं होता है कि व्हेन यू मिक्स द टू सॉल्यूशंस 1:1 रेशियो और 95:5 रेशियो जो कि लोग बोल रहे हैं, उसी रेशियो पे वो एजियोट्रॉपिक मिक्सचर ऐसा बिहेव करेगा, और इट विल बिहेव एज एजियोट्रॉपिक मिक्सचर एट ऑल कंपोजिशंस. फॉर एग्जांपल, यू मिक्स वाटर एंड इथेनॉल विच शो पॉजिटिव डेविएशन एंड यू ट्राई टू आइडेंटिफाई कि at which composition they will behave as azeotropic mixture, और आपने आंसर दे दिया कि at all compositions, तो वो गलत हो जाएगा. It will be incorrect. Okay, so if you say that at all compositions it behaves as azeotropic mixture, that is incorrect, because you can see a maxima which is obtained only at a particular composition. You're seeing a minima which is obtained only at a particular composition. So only at a specific composition you will obtain a azeotrope. Only at a specific composition you will obtain a azeotrope. So हमने अभी तक आइडेंटिफाई किया कि पॉजिटिव एंड नेगेटिव डेविएशन कौन से सॉल्यूशंस दे रहे हैं. सो यू विल next in the next slide I'll show you that when there is a solution with positive deviation, there is a particular composition only at which we observe a azeotropic mixture. Okay, we observe a azeotropic mixture. I'll get to that. Okay, I'll get to that just. Okay, so just remember that this plot shows that the boiling point of an azeotrope is either, tell me something, if vapor pressure is more, if there is positive deviation, that means vapor pressure is more, what will be the boiling point of the azeotrope? What will be the boiling point of the azeotrope? यार आपको यहां से यहां तक जाना है. This is the vapor pressure. The vapor pressure will keep on changing. Okay, the boiling point will be less. When vapor pressure is more, boiling point is less. Vapor pressure is more, boiling point is less. Okay, so when boiling point is less, the positive deviation, when a solution shows positive deviation, it will form a boiling mixture whose temperature is less than that of the components in azeotropic. ठीक है, so azeotropic mixture का जो boiling point होगा, उसका that boiling point will be less than that of the components, whatever components you are mixing, if it is positive azeotrope. If the boiling point, if the vapor pressure is less, the boiling point will be more at the azeotropic point. At the azeotropic composition, the boiling point will be more. ठीक है, and more with respect to the boiling point of the two components that you have mixed. Boiling point will be more as compared to two components that you have mixed. So that is the reason we get two terms. Okay, we get two terms, and these two terms are minimum boiling azeotropic mixture and maximum boiling azeotropic mixture. Okay, दिव्यांशु अगर साइंस इतना ही इजी रहता, so Marie Curie would not have died due to cancer. So just reading about it, you should know that Marie Curie died due to cancer, due to leukemia, and she died in the year 1934 because she spent so much of time working for radioactivity. Science is not easy. It requires a lot of effort. Okay, and the diary in which she had written all her observations is still very, very radioactive, and it will still remain quite radioactive for about 1500 years. So people do a lot of effort. जो rank 1 लाते हैं या फिर कोई भी rank qualify करते हैं, okay, कोई भी rank qualify कर रहे हैं, कोई भी college में जा रहे हैं, they are at least putting a lot of effort. They're putting a lot of effort. So science is not very easy. Okay, अगर आपको easy वाला part देखना है तो वो actually में एकदम superficial है. जैसे आप नीचे अंदर जाते जाओगे, it will become difficult. That's for everything which requires effort, for even a game. Okay, so there are two types of azeotropes. Okay, two types of azeotrope. One is a minimum boiling azeotrope. Minimum boiling का मतलब, okay, minimum boiling azeotrope means a solution or a azeotropic mixture whose boiling point is lesser than that of two components which are mixed. Okay, boiling point, minimum boiling azeotrope means the boiling point of the azeotropic mixture is less than that of the components which is mixed, and this is possible only when there is positive deviation. Let's understand it using an example. So let's look at example. I hope you can see this. Okay, I hope you can see this. This is component A. Let's say we are taking certain solutions. This is component A. Component A, water. Yeah, acid plus water is negative deviation all the time. So component A, water. This temperature is its boiling point, 373 Kelvin. Component B is ethanol. Water, ethanol, what kind of deviation will take place? Bataiye, what kind of deviation? Water plus ethanol is positive deviation. This table is of positive deviation. Now, when you make an azeotrope, then the composition of A, this is A, composition of A is 4%. That means a water ethanol mixture is not forming azeotropes at all compositions. It is forming a azeotrope when water is 4% and ethanol is 96%. Is that understood? Water is 4% and ethanol is 96% by weight. Is that understood? So यहाँ पे लिखा हुआ है composition of A in azeotrope is 4. That means water's composition is 4% by weight. Okay. Now let's look at the boiling point of azeotrope. Boiling point of azeotrope क्या है? 351.2. 351.2 Kelvin. What is the boiling point of water? 373. Okay. What is the boiling point of water? 373. Boiling point of ethanol? 351.3. So isn't the boiling point of azeotrope coming as lesser than either of these two? Okay. You cannot determine the ratio. This is done experimentally. Okay. This is done experimentally. So aren't you seeing that this boiling point, isn't it less than the boiling point of ethanol as well as boiling point of water? Yes. So that is known as a minimum boiling azeotrope. Let's look at some other examples. Water and ethyl acetate is mixed. Okay? Water and ethyl acetate is mixed. Boiling point 352.6, boiling point 373. What is the boiling point of azeotrope? 346.4. 346.4. Obviously, just you have very rightly articulated that the boiling point will be more. Again, not the azeotropic mixture is not obtained at all compositions. ये किस composition पे हो रहा है? When there is 11.3% of water and 88.7% of ethyl acetate. Is that understood? So किसी एक particular composition पे वो azeotropic mixture बनाएगा. But when it forms azeotropic mixture, it is only possible for positive deviation and negative deviation. As a percentage increase, increase in boiling point decrease. I didn't understand your question, Devianshu. Okay. Let's take up CCl4. Boiling point of CCl4 349.8. Boiling point of methyl alcohol 337. When 79.49% of CCl4 is present, then it forms an azeotrope. और azeotrope का boiling point आप देखिए क्या है? 328.7. So 328 is less than either of these two. Okay, 328 is less than boiling point of methyl alcohol as well as boiling point of CCl4. Is that understood? कि minimum boiling azeotrope क्या होता है? Minimum boiling azeotrope उस system को बोलते हैं percentage composition azeotropic increase the boiling point. Again, you have not framed a correct statement. Please frame a correct statement so that it will be easier to understand. Now CHCl3 CH3OH 87.4 326.4. You do not have to remember these values, you just have to remember the idea that minimum boiling azeotrope is possible for solutions which show positive deviation, okay, is that understood? Let's move ahead. Let's analyze it in this system. This is given, this is vapor pressure versus mole fraction plot for ideal solution, but if it is for a solution which shows positive deviation, I will be having something like this. The vapor pressure of each of them will increase. The vapor pressure of each of them will increase, and you will get a plot like this. Plot is given in NCERT. So, ये आपको जानना चाहिए. This is something that you should know. Why it is an increase? Because it is showing positive deviation. Positive deviation कब होता है? When the new interactions between different molecules is less as compared to the previous scenario. Okay? Very good, Just. Yeah? Very rightly articulated. Okay, so let's talk about what is the maximum boiling azeotrope. Maximum boiling azeotrope में क्या होगा? Maximum boiling azeotrope will be written for which kind of solutions? Can you tell me? Solutions which show negative deviation. It will be written for solutions which show negative deviation. So negative deviation में क्या होना है? The vapor pressure will be less than that we calculate using Raoult's law. Okay? Negative deviation में minimum boiling azeotrope मिलेगा. You can see maximum boiling azeotrope is the one which shows negative deviation from Raoult's law, exhibits a minima in vapor pressure versus composition. Okay? Exhibits a minima in vapor pressure versus composition. So let's take up some examples. कुछ examples देख लेते हैं. Okay, let's look at some examples. Example is, the first example is HNO3 and H2O and HNO3. Okay, H2O and HNO3. H2O is boiling point is 373 Kelvin. HNO3 359 Kelvin. Now when the azeotropic mixture is formed, you can see its boiling point. What is the boiling point? बताइए. Sorry. Okay, you can see its boiling point. The boiling point is 393.5 Kelvin. So this is 359, 373. Isn't the boiling point of the azeotrope higher? Exhibit का मतलब दिखाता है. Okay, you can use a dictionary always, no? So percentage composition of A in azeotrope is 68%. मतलब when H2O is 68% and HNO3 is 32%, then it forms a azeotrope. Both I have already explained this. They show negative deviation. Okay, they will show negative deviation. Okay, negative deviation is shown because when you take HNO3 and put that thing in water, they initially in their respective solutions have only hydrogen bonding, but when you put them together, it will form H3O plus and NO3 minus. H3O plus is an ion, NO3 minus is an ion. इन दोनों के बीच में attraction होगा, and this attraction is electrostatic attraction, and this electrostatic attraction is more stronger than hydrogen bonding. So when H2O and HNO3 are mixed together, they do not want to escape out in the vapor state, and okay, they escape out in the vapor state, and because of that the solution shows negative deviation. Okay, so this is 393.5. Let's take H2O HCl, कोई same scenario, 373 353. You can see 373 353 and boiling point of azeotrope देख लो. Okay, so the same is true for others. Exactly the same is true for anything which is showing negative deviation. Okay, so negative deviation will involve things which react with each other. Okay, so the reason could be slightly different, but it is more or less they were almost the same. So this boiling point of azeotrope is 381.6, which is higher than both of them. Okay, अब देख लीजिए, it is higher than both of them. Phenol and aniline, they react together. Okay, phenol and aniline react with each other, and because of that, ये 457.4, 455, and the boiling point of the mixture, you can see it is not very large, but it is large. 459.2, 457, 455. And sir, there is dependency of freezing point. See, the thing is, if I am talking about vapor pressure determines boiling point, vapor pressure is also determining freezing point, it is also determining osmotic pressure. ये हमने पहले पढ़ लिया है. So what does it mean? That since we are not analyzing it, but yeah, there will always be a dependency, but we would not take freezing point to compare over here, because that will be a different scenario altogether. We are taking boiling points or vapor pressures to compare. Cool. CHCl3 acetone, I told you earlier that CHCl3 and acetone react to form chloritone, and you can see boiling point is 334, boiling point is 329, and boiling point is 337. So boiling point of a negative, the one which shows negative deviation, and the azeotropic point will be higher than that of the combining liquids. Will be higher than that of the combining liquids. I have told chloroform and acetone to बता ही दिया. Last one option. Chloroform and acetone react to form chloritone. So this is what happens. Clear? Now, can you tell me what would the plot look like if this is for Raoult's law? What would be the vapor pressure versus composition plot? What would it look like? It will look something like this. Okay, ये इस तरह का दिखेगा आपको. ठीक है? This it is the vapor pressure versus composition plot for a solution which is showing negative deviation will look like this. Clear? I hope this is understood. So when it is showing it like this, can you observe a minima? This minima is obtained at this composition, and for this composition, the boiling point will be that of the azeotropic mixture. So this is the azeotropic point. I can say that this is the azeotropic point, and if this is the azeotropic point, the boiling point at this instant, at this composition is this because of the boiling point is because of this boiling point of this composition will be higher than that of this one and this one. Okay? We are not talking of equilibrium. Equilibrium is not okay. So P2 intercept is more Y. It is not which P2 or PB. I am not able to understand which. I'm not. What is your question? P2 intercept. What is P2? Are you talking of this one? So it is higher because its vapor pressure is higher. Okay, so the solution B has a higher vapor pressure. B का vapor pressure ज़्यादा होगा क्योंकि उसकी volatility हो सकता है ज़्यादा है. Okay, it's quite possible कि a substance whose boiling point is less, for that the vapor pressure, a substance whose boiling point is less, for that its vapor pressure is higher, and उसका वेपर प्रेशर ज़्यादा होता है. इट्स अ पर्सनल कैरेक्टरिस्टिक. ओके, आप उसको राइट में कंसिडर कर रहे हैं इसलिए ज़रूरी नहीं है कि वो ज़्यादा है. इट इज़ नॉट लाइक दैट, बट इट्स वेपर प्रेशर इज हायर और इट्स बॉइलिंग पॉइंट इज लोअर. ओके, सो वेरेवर यू गेट द मिनिमा, उस पॉइंट पे जो कंपोजिशन होगा दैट विल बिकम द एजियोट्रॉपिक पॉइंट. ओके, दैट विल बिकम द एजियोट्रॉपिक पॉइंट. ओके, सो लेट्स अंडरस्टैंड दिस. This is the boiling point versus composition curve. Have you seen these plots? कभी आपने ये plots देखा है? Have you ever seen these plots? These plots are given in Narendra Avasthi or any advanced level question books. You haven't seen these plots. So remember, if I draw a temperature versus composition, I have already explained this earlier that the lower one is for liquid, the upper one is for vapor. Lower one is for liquid, the upper one is for vapor. Okay, lower one is for liquid, the upper one is for vapor. Okay, lower one is for liquid and upper one is for vapor. Now the point is, if you would remember, for an ideal solution, the plot looks like this. For an ideal solution, the plot looks like this. Ideal solution के लिए इस तरह का दिखेगा. But for a non-ideal solution, you are seeing two leaves were connected to each other. Okay, it's known as a phase diagram. Okay, for a non-ideal solution, you can see that it is shown like this. Can you see? Now let's say this is component A whose boiling point is this. This is component B whose boiling point is this, and this is the boiling point of a particular composition. Okay, this is the boiling point at a particular composition. At this particular composition, can you observe that the boiling point is lesser than both of them? Isn't it? At this composition, can you observe that the boiling point is lesser than both of them? Yes, this is boiling point. You can see that this is temperature versus composition. So can you observe that at this point, at this composition, the boiling point, this is temperature, so this is boiling point. Boiling point is lesser than that of this component and this component. Yes, so if it is less, so what kind of azeotrope have we drawn this plot? For what kind of minimum boiling? Very good, minimum boiling. मिनिमम बॉइलिंग एजियोट्रॉप. ठीक है, ठीक है. सो minimum boiling azeotrope will be over here, and this is for a solution which shows positive deviation. This is for a solution which shows positive deviation. If we analyze that one, boiling point of component A, this is boiling point of component B, and the boiling point at this composition is higher than either A or B. So this represents maximum boiling azeotrope, and this is the composition when we obtain a azeotropic mixture. Not at all compositions, at that composition when it is highest, at that composition when it is lowest. Is that understood? At that composition when it is lowest for minimum boiling, and that composition when it is highest for maximum boiling, we obtain the azeotropic mixture. Okay, is that understood? So this is for minimum boiling and this is for maximum boiling. for maximum boiling. I hope this is understood. This is pretty much self-explanatory. Let's talk a bit about minimum boiling azeotrope. What features can we observe in a minimum boiling azeotrope? So if this is a minimum boiling azeotrope, this is boiling point of component A, this is boiling point of component B. Okay, now assume that I start distilling this. I start distilling at point X. Okay, do you remember evaporation, condensation, creation of vapor, condensation? Let's say I obtain Y. Evaporation, creation of vapors, condensation. याद है आप लोगों को? Do you remember that this is what happens? This is the lever rule to predict what will be the composition of the distillate or what will be the composition of vapor. If you remember this, please say yes. ये हमने पहले पढ़ा दिया है, I guess, in a previous session where we had discussed boiling points, where we talked about fractional distillation. So in the video of fractional distillation, we had learned we boil this, it creates vapors, and at this point X, can I say the composition of A, composition of B. Now when the distillate is obtained at composition Y, when the distillate is obtained, अब distillate में क्या observe कर रहे हो? What you are observing in the distillate is that the composition of A has increased. So composition of A, or I say concentration of A at Y is more than concentration of A at X. Can I say this? At Y, can I say that amount of A at Y is more than the amount of A at X? Similarly, can I say that the amount of B at Y is less than amount of B at X? Clear? I can very well say this. Now I boil this, I get over here, and I get to this azeotropic point A1. I get to this azeotropic point A1. Clear? I boil this solution which I obtain over here, and I get this azeotropic solution A1. Okay? Now can I say at A1, or let's say represent it as A1, concentration of A at A1 is more than concentration of A at Y. Similarly, concentration of B at A1 is even lesser than concentration of B at Y. So हमारे पास A का amount धीरे धीरे increase करता गया और यहाँ पे आके मिल गया हमें. I have got that minima which I was expecting. Now when I boil this solution, so I'm erasing this part, I boil this solution. Do I see a vapor plot corresponding to this liquid plot? So lower wala liquid hai, upper one is vapor. Can I see a corresponding vapor plot with respect to this liquid plot? Are you able to see a corresponding vapor plot with respect to this liquid plot? बताइए, are you able to see a corresponding vapor plot with respect to this liquid plot which is at this lowest point? We are not able to see this. Okay, we are not able to see this, and since we are not able to see, when you boil this liquid, the vapor's composition will remain exactly the same. At this point, since we do not get a vapor composition plot, the composition of the distillate or the vapors will remain exactly the same as that of the liquid. दूसरी जगह पे आप चेंज कर रहे थे, आपने बॉयल किया, इस टेम्परेचर पे कुछ और वेपर्स मिला, उसको आपने कंडेंस कर दिया, बट यहाँ पे वैसा नहीं हो रहा है. ओके, सो दिस इज द सिनेरियो विच एग्जिस्ट्स फॉर दिस मिनिमा, and because this minima is obtained, I do not get a corresponding vapor plot, and because we do not get a corresponding vapor plot, अब जितनी बार उस पॉइंट पे बॉयल करते रहोगे, your composition will not change. ओके, यहाँ पे कंपोजिशन चेंज कर रहा है, x का कंपोजिशन आपने बॉयल किया and you have boiled it and you have obtained something like this over here using the lever rule, but यहाँ पे आप नहीं obtain कर रहे हो. Okay, so this is why the composition of the azeotropic mixture does not change. So you can analyze the same for maximum boiling azeotrope as well. So at minima, no condensation. It's not that no condensation occurs, but the vapors will have the same composition as what you are boiling. Vapors will have the same composition. More volatile will not escape out, less volatile will not remain in, the composition will remain the same. Usually होना क्या चाहिए? More volatile should escape out, less volatile should remain, but if it is azeotropic, the composition remains the same. Okay, the composition will remain the same. So this is the same that we can analyze for maximum boiling. Try to do it on your own, and with this we end today's session. The next session is of Pulkit Sir at 6 o'clock, which is on inverse trigonometric functions. Please do stay for that, and please don't forget to like, share and subscribe our channel. Please don't forget to hit the bell icon so that you're always updated with the amazing content. The next session we would be taking some questions. We'll try to solve some problems on basis of whatever we have covered in lecture 1 to 10. So please do review them so that we'll be doing a problem solving session in the next class. Okay, chaliye. So we'll continue from here in the next class, and until then, bye bye and have a lovely time ahead. How many are watching?